Okay. Is that, can you see it?
Yes.
Yes, yes.
Okay, great. Okay, thank you. If it's okay, I'll start. Yeah. Okay. So thank you for this time, and I've been at the Scala Matsuri last year, and I was very excited and to be virtually joining you. This session seems very it's really great. I like the whole setup with the Discord and things like that. So today I'm going to be sharing with you some updates on Scala with GraalVM. We have been working a lot behind the scenes. From the GraalVM team, as you know. And so we're happy to get any feedback or interactive discussions that you have also. So do you want me to stop for the translation, or do you want me to keep going the presentation? How do you want me to, as I'm talking, would you be translating, or should I stop every 10 seconds or something? Okay, keep going. Okay, good. So the Scala project and our work together with GraalVM has been a decade of research at Oracle. And what we actually built over the 10 years, as you know, with Dr. Thomas and his team, was a multilingual VM that can be 100% compatible with any language. So it will meet or beat the performance of all the single language VMs. So this is almost a 10-year project. And as you know, over the last 2 years, we have gone production, and GraalVM is now available in production for everybody to use for, on the JVM stack and the languages like Scala. And of course, you have others like Groovy and things like that as well. But also includes things like R, Ruby, Python, and so forth. So I wanted to kind of, summarize the capabilities of GraalVM into 4 main areas, and then show how the importance of GraalVM is for Scala compilation, workloads, and things like that. So the first thing is that GraalVM is very important for traditional workloads, meaning if you have high CPU intensive, large amount of calculation types of workloads, and you want to reduce the CPU, like say by 20%, instead of using 10 machines, maybe you want to use 8 machines. These are the kind of capabilities it can bring immediately without changing the code. So this is what we call the GraalVM just-in-time compiler. It is built on Hotspot, and all the languages that have been using Hotspot can automatically use the GraalVM just-in-time modern next-generation compiler. It's part of what we call the just-in-time. So to use this, you do not need to do any code change, right? The second part, which is the ahead of time, as you can see for some of the command line apps, things like that for Scala and SVT and all that, or even for Apache Spark, we've seen it. When you run some of the workloads in native mode, especially microservices, the startup time is much faster. So it becomes fast startup, lower memory footprint, and also the application size is reduced. The one for the traditional workloads, which is the just-in-time, that one is to help you get more peak performance, right? And of course, better reduced latency. The third area is the polyglot. So here, maybe you want to mix and match code without going into multiple runtimes. So you can have a polyglot from Scala. You can call R to do some plotting of data science and things like that. And then, you could be also looking at third-party code that you want to build in terms of dependencies like host and guest VMs and so forth. And then, of course, is the embedded. You can run this embedded code on a lot of third-party, devices and so forth as well, right? So, and all that. So the 3 main areas in terms of benefits that you will see for Scala would be that, you get a lot more faster for your real-world benchmarks. So we'll share some benchmarks. There's many patented optimizations that are built behind the scenes, under the hood, so you can compile to native executable and leverage multiple languages. Um, and of course, leaner means it's a reduced footprint, so you can get higher throughput with lower CPU usage and also reduce garbage collection overhead. So let's go a bit more in the details, right? On GraalVM, the compiler, and how it's suitable and useful for Scala. So the first thing is that it's written in Java, so that the reason is obviously that it makes it more modular, maintainable, and extensible, right? So all the JVM stack of languages can benefit from this. Comes in two flavors. There's a lot of optimizations, as the research paper already written on this, especially partial escape analysis, path duplication, and priority inlining. So a lot of this does what it is, optimizing the code, doing things like dead code elimination, and so forth, right? So a lot of it, as you know, we see this is a Java example, but kind of similar in that sense to Scala as well. So if you're looking at, writing code in terms of streams, collectors, and things like that, what it does is it optimizes it, and you're able to get better decision to remove a lot of this abstractions and things like that. So it gives you that production quality code, right? And it's more performant code and things like that. So why is GraalVM good for Scala? Because the Scala compiler basically is a lot of bytecode for accessors, lazy, um, you know, case classes and things like that, right? So, and we realize that there's in the abstractions, there's a lot of concise syntax and advanced type system and things like that. So with GraalVM, what we can do is basically we are able to give you a lot more on how the decision to actually remove these abstractions and make the code more performant and things like that, right? Because we realize there's many layouts and many functional calls that happens natively in Scala. So this is very important, and that is why it actually proves that for this kind of for Scala compiler and also the type system and things like that, and the advanced type system, and because there are many abstractions, Scala becomes a very good choice for GraalVM. And so we see that in terms of the performance benchmarks. So here we look at the performance benchmark of different types of Scala workloads, including things like your k-means, your there's a geo-mean on the right-hand side, and we can see that the performance improvement over the average versus the regular, JDK8 when you speed up those same workloads is almost about 40 to 50% faster compared to what is before. And these are actually published with university research together with Oracle Labs at Renaissance.dev. So it's a pretty interesting one. The link is actually below, so you could definitely go in there. It gives you details on how these workloads were run as part of the performance evaluation, and you can also run it yourselves as well, right? So you can see below a lot of different types of Scala specific ones, and even some of the ones like naive Bayes theorem can go up to even larger numbers and so forth as well, right? So even when we see that Scala just running it from the get-go, that means you're using the GraalVM compiler just as a JIT in the hotspot. You're running Scala streams. You can see already that there's difference between when you're using it with GraalVM. It's almost in the order of 4 to 5 times faster. And if you do this test, you'll be able to see that. We've run this several times actually. And of course, in the future, as your packaging code is native, makes it better for isolates and so forth. So once you're compiling, GraalVM, especially comparing the SBT compilation for different projects, you'll see that, it's almost a 20% difference here when you look at Akka and also the different types of ones like Guardian front end and so forth. Here you can see that it is almost like a 20% difference. So that means like if you're using, say, for example, 10 machines, you're like reducing it to 8 machines. So let me just give you an example of a simple, Akka, basically code that has been native image compiled together with GraalVM, and the HTTP servers serving some responses and so forth. So what I'll do is maybe I'll just do a new share and share my command line, and you can see that. So this is my command line. Basically what it is I've actually, if you look at it here, I've created a essentially a Akka native image of a HTTP server, right? So what it's basically doing is that it's going to be giving your the ability to run the HTTP server in a much faster startup and so forth. So the way that's going to happen is, let me just share that really quick. So I've already compiled it to native image, and after the server starts, I'll be able to access this URL, and which will give me a HTTPS request to GraalVM homepage using the Akka HTTP client and return the size of the response, right? So I'm going to do that as soon as I run the code here. So I'm running it here. So that's the native image, right? So you can see the Akka Graal native image, and I'm going to be running it. So once I run it, it's actually listening on port 8086. So if I do a new share and I show you my Chrome browser here, you'll be able to see in there that the size of, as I indicated, the response coming back from the GraalVM homepage from the Akka HTTP server, right? So this is a simple, basically demo just with Akka and GraalVM, right? So you're able to see that accordingly, and it's running and things like that. So I'm just going to be exiting out of that and then stop share. Let me go back to my original screen where I had my presentation running, and you can see. So that's Akka as an example of a demo with GraalVM native image. And if you're interested, definitely can share more details on that as well. Moving on, for native image, from a very simple example, earlier you saw Akka, but you can also use it for other simple examples. Like if you wanted to do hello world, you can time it and then you run a native image, and you will see the significant difference in terms of the startup speed and the low memory footprint and so forth. The interesting thing, about the native image is that it does a static analysis. So a lot of the application libraries and third party so forth going through a point-to-point analysis. So there's an application initialization phase, and then the AOT code is compiled, and then there's object heap snapshot and so forth on host VM. And so with this, what happens is then you are able to deploy this on different platforms. For example, like on desktop applications with Scala FX, and also on Android and on iOS, right? So this gives that whole Scala ecosystem the ability to run on third-party systems as native code and integrate it into other systems, like cross-platform or even ARM support and so forth. So that's a very important piece. And with that, what we see is that it's ready for wide adoption. So we've sorted out, a lot of the unsupported features now. You can try it out on the framework like Akka and play. Earlier you saw a simple demo of Akka, and then you can, it's easy to install and test. So we're actively working with the community according to this. Another interesting example over here is on the native image is that we can further make we can learn from the profile, right? Because we can instrument the binary, because what we are producing, as you know, is a static executable. So we build from the ground up. We can learn from the profiles. We collect the profiles, and we understand the code that is that it's going to be used, and then we are essential for performance. Make it even more performant. So it requires running relevant workloads before building the image, right? So you can run it, and it's an instrument. It creates this iProf, and then you run native image with PGO, and then you can even get faster startup and things like that. So here, when you see examples comparing, command line tools in Scala C and others, there is significant differences between, the community and of course the enterprise edition. It's almost like, 40, 50%, 30, 40% difference between the command line tools. One interesting point here is that, we also have, when we look at, I wanted to go back and maybe just mention, on one of the slides that earlier that I did mention, was that when we look at this specific code here, especially this code, and why GraalVM is good in the sense, because on the left-hand side, what we're seeing is, your lens, library from Monocle, right? So and others, like on the right-hand side, the shapeless agent, right, and app. So since there are many layouts and functional calls and things like that, this is where the performance aspect of GraalVM then kicks in. So you can have the decision to remove a lot of the abstraction and so forth as well. And that's why it's good, especially with where there's bytecode, a lot of pattern matching, things that are going on behind the scenes. Right. So going back to the some examples on where we see this running today. So one of the biggest deployment here, the biggest one obviously is in Twitter. Twitter is using it for Scala workloads, and they've shared a lot of use cases. Especially they're using it as part of their microservices, part of their graph and search and things like that. And deployed it through all their they dispatch their tweets. They're running on Scala and things like that. We also have the Oracle Cloud Infrastructure has been using GraalVM for 25% reduction in GC and about 10% improvement in transactions. So it's been running for many hours without many issues and things like that. With the native images, the benefit, of course, is that you get that cross-platform support, and you're getting about 5 times less memory and more than 100 times support. Also, in terms of frameworks, we are seeing that people are picking up, like whether it's Halidon, Micronaut, Quarkus, and things like that. They're able to support this and get 4 or 5 times, 15 times difference for low memory, and then obviously fast startup becomes a big thing. It's interesting to note that when we compare just in time in the native image mode, there's a drastic resource usage. As you can see in red is where all the resource utilization is happening for CPU. And then on native image, you get more short and more consistent performance and so forth. And then that way you're actually saving on CPU machine and so forth. Other areas we see on Apache Bench also is when we compare the microservices and we're comparing community and also the enterprise edition, we see a lot of differences, 16% difference, and also almost 1,500% higher when it comes to requests per second, and you're comparing your GraalVM JIT versus your native image from the get-go, right? So that's an important one. So these are just some of the highlights we wanted to basically share on how GraalVM can help for Scala workloads and how it's faster and smarter and leaner. Previously, I also had a GitHub page on how you can test a lot of these workloads, and I'll be able to share that so you can go through yourselves on how to run the JIT just in time and also the native image mode and also polyglot capabilities accordingly there as well. So that's a summary of how GraalVM can help you accelerate your Scala workloads, and I'm happy to take some questions you have. I'm available on Zoom as well now, so I'm gonna leave it as maybe on this note here, and if there's any questions, I'm gonna relate to Noriaki-san if you're on the call, please.
Okay, thank you for your presentation. 発表ありがとうございました。Everyone, please give him a big round of applause. 拍手を皆さんお願いいたします。パチパチパチパチパチパチ。
Thank you. Thank you very much.
Yeah. Do you have any question? 何か質問はありますか？
I see some in the chat window, yeah. Great, thank you. I see some, the 8888, that I guess that means the claps, right? Yes.
Yes, 888.
Yes, 888
that is clap.
Okay, that's very nice.
Big clap.
Oh, big clap. Okay, thank you. And there's there's a lot more interactive demos I wanted to share, but with the virtual capabilities, I think there's a lot more that we can do also. So, but thank you for that. And if there's any questions, I'm free to answer those as well. So.
Oh, that's good. Okay. Okay, again, everyone, please give him a big round of applause. Thank you very much for this session.
質問したいんだけど、
Oh,
英語はあんまり
okay.
得意じゃないんですよね。
Do you have any question? Okay.
ちょっと一回日本語で言いますけど、
はい。
メモリの消費量がかなり減るのはすごく魅力的だなと思ったんですけど、それってそのグラールってそのエンタープライズエディションとコミュニティエディションがあったと思うんですが、エンタープライズエディションだと、かなり違うということですかね。どうしたらいいかな。
はい。Anyone can translate? Can anyone translate of the question?
Well, I'll try to speak English. So, the memory
Okay.
consumption, less memory consumption is very attractive, I think. So, I remember that the GraalVM have the Enterprise Edition and the Community Edition. And memory, so reduction of memory consumption is enterprise specific, or the same feature is on Community Edition?
Yeah, so that's a good question. So basically, you are going to get, even for both cases, you will see differences, both for memory as well as for. I was just going back to the slide where actually it had the speed up. So you saw the speed up, and you will see it in both the community and also enterprise. But then there's a difference on the amount. That means that you will get more. In terms of with the enterprise native image, you get even more memory, less memory utilization and faster startup. So the difference is higher with enterprise edition. But you will also see some improvement with the community edition as well. Yeah, there are specific features for enterprise edition, like for example, security, the secure managed sandbox, and other more specific types of optimizations and so forth. So there are differences, and on top of it, there are areas that are there are other areas in there as well. So and you'll be able to see it once you test it. Yeah. So.
ありがとうございます。Thank you for. コミュニティエディションでも、メモリーは少なくなるんだけど、エンタープライズだともっと少なくなるよと、効果があるよという話でしたね。ありがとうございました。
はい。Is there any other questions? 他に何か質問があればどうぞ。なさそう。アミットパルさんはこの後も、いつでも、質問していいよとおっしゃっていたので、ぜひ声をかけて、聞いてみてください。それでは、このセッションを終わりとしたいと思います。皆さんどうもありがとうございました。また拍手お願いいたします。はい。
Thank you. Arigato gozaimasu. I really enjoyed it. Again, thank you very much. And I think we finished ahead of time. So it's a native minute style, right? So we finished the session ahead of time by 15 minutes. Right. Yes.
That's good.
Okay. Yes. Thank you.
Thank you very much.
Thank you very much. Okay. Bye-bye.
はい、この後フリータイムということで。
そうですね。他のセッションまだやってるみたいなんで、
はい、見ていただいてもいいですし、はい。そうですね。ここを開けておくので、飛び入りで何かやりたい方いたら、全然 OK でございます。はい、質問とかでもいいですよ。いる間は。はい、どうぞ。